Now that we have discussed how we're going to organize data in graph or in table formation, now we're going to look at how can we present this data in graph formation. The first graph that we're going to look at is a histogram. A histogram will be used to represent frequency distributions. These are going to be bar graphs and are going to be used for our grouped frequency distributions, the ones where we have the class limits, class boundaries. Key things to note is that there's going to be no gaps between the vertical bars, and we're going to use the class boundaries along our x-axis. So when we start to draw it, it's going to look like this. Our frequency is going to go along our y-axis, and our boundaries are going to come across the x-axis. And we're going to have bars that touch. There's going to be no gaps in between these bars here. Okay, we're going to make sure that they all touch. So let's look at an example of this. Recall back from our previous lesson where we constructed a frequency distribution for the 30 of the world's tallest buildings. Now we want to represent this information in a histogram. Well, let's look back at our frequency distribution here. We have the class limits, and we found those last time, recalling that our class width was 9 and we added 9 down. And then look at our class boundaries. Remember, that is taking our 54 and subtracting 0.5, and our 62 and adding 0.5. And we did that all the way down as well. Once we do this, we're going to use our class boundaries column and our frequency column. And we're going to start with our 53.5 boundary, and we're going to end with our 116 boundary. So when we start to draw this, what it's going to look like is, here is my lowest boundary, my 53.5, and then I'm going to have my 63.2, then I'll have my 71.5, and I'll continue on down until my 116.5 along the x-axis. And I will draw my bars here at my hash marks so that I don't have anything really labeling the bar itself. It's the boundary, because I have 7 between 53.5 and between 63.2. So there's nothing in between here on my x-axis number-wise, but my bar goes from hash mark to hash mark, using the boundaries as my hash marks. So let's see what a completed histogram will look like. Here I have done my histogram. Notice I've done my boundaries, 53.5, 62.5, 75.5, with my hash marks here. I've done my frequencies over on the y-axis, the left-hand side. I have labeled my axes. My y-axis is my frequency, and my x-axis I label according to my problem. For instance, in this case, it's the number of stories for a building, so I labeled it with stories. And then I drew my bars up, making sure that they came to the hash marks. So this was my first class, went up to about 7, and then this one goes to 6, 8, and so forth. So this is a completed histogram for the number of stories in 30 of the world's tallest buildings. Make sure that your bars touch and that you're using the boundaries on the x-axis. Another way to represent our data is with a frequency polygon. A frequency polygon is a special line graph used again to represent the frequency distributions. It must start and end at 0. We're going to use the class midpoints this time instead of the class boundaries. So it's going to be really important for you to distinguish between the graphs. Do I use the class boundaries or am I using the midpoint? With the line graphs, or with the line graph of the polygon, we're going to use the midpoint. And so when I do this, I'm going to have, if I go here, I'm going to have midpoints here. I'm still going to have my frequency along the y-axis. I have to be a little bit careful because my normal midpoints are going to be in here. I have to add additional midpoint. So this midpoint has to be added and this midpoint has to be added. So I'm going to use my information that I already know as far as my class width, and I will take whatever number is here and subtract my class width to get this number, and I'll take whatever my midpoint is here and I'll add my class width to get the number for this. The reason I do that is so that these have a point here and here, so that my frequency polygon looks something like this. We'll look at the one for our particular problem in a moment, but a polygon must be a closed figure, and this closes us off with this x-axis, and so we have to start at 0 and end at 0. Let's look at our example of the 30 tallest buildings again. We first must find our midpoint. We didn't do this in the last exercise. I did discuss what a midpoint was. What we do is we take this and we find our average. We find the average of our class limits. So if I kind of move this up a little bit, I take 54 plus 62 and divide it by 2. So that gives me 118 divided by 2, which will give me 58. And that's where I get this midpoint. And I'm going to do that for each one of these. My frequency stays the same. I'm just finding the midpoint. I'm finding the average of the class limits. That way I have these numbers to be able to put along the x-axis. If you recall, our class width was 9. So if I take 58 and subtract 9, that's going to give me 49 here. And if I take 112 and add 9, that's going to give me 121 here. Those are the ones that I'm going to have a frequency of 0 to close off my figure. So let's see what this figure actually looks like. Notice I've got my class boundaries, or I'm sorry, my midpoints here. We started out with a midpoint of 58 and went to 112. Here are my added midpoints of 49 and 121. And looks like my arrows got off a little bit. These arrows should be here saying that it's anchored here and here, meaning that it touches my lines. Okay? So again, remember that it must have a class at the beginning and a class at the end with a frequency of 0 to close off our polygon. It's very important that we add these two classes. Otherwise, it's a line graph, it's just not a polygon. It's not this special type. One other type of graph that we're going to look at is the ogive. Kind of looks like ogive. It's an ogive. It is still a special line graph, but instead of using frequencies, this one's going to use the cumulative frequencies. And we're going to use the upper class boundaries along the x-axis. If you recall, we did a cumulative frequency table at the end of the last lecture in which we had the less than, and we started out with 0, and then we were using the class boundaries here. That is the table that we're going to use for the ogive. So you need to have a cumulative frequency table in order to do the ogive. So let's look at our cumulative frequency table that we constructed last time. Remember, the first line is always our smallest boundary, the 53.5, and our first cumulative frequency is always 0. And then we use all of the other class boundaries all the way up to our very largest class boundary. And we take our frequencies and we add them up. Because if you recall, we had the class frequencies of 7, 6, 8, 4, 1, 3, and 1. And so what I've done is taken 7, and then 7 plus 6, and then those numbers plus my 8, and then those numbers plus my 4, added the 1, added the 3, and added the 1. Okay, so we're going to use these numbers right here along our x-axis and these numbers along my y-axis. And we'll get a line graph that looks something like this. Notice I have my boundaries down along the x-axis and a cumulative frequency here, which this should be labeled with cumulative frequency, and this should be labeled with the number of stories. Always make sure that you label your x and y axes. Notice how this is going up. It starts at 0 and it's going up. It's not at the constant rate that it's going up, but it's always going up until we hit our n, which is 30. That is how an ogive is always going to be. It never goes back down. It's a constant increase. So when you're looking at selecting a graph to draw, you want to go ahead and draw and label your x and y axes, and then choose your suitable scale for your frequencies or cumulative frequencies. Represent the class boundaries for the histogram or ogive, midpoint for the frequency polygon, and then plot your points and draw the lines and bars. Okay? This is for drawing any of the graphs that we've discussed. Going back to the histograms a little bit, we can discuss their shape some. The most common shape is the bell curve, the bell shape. meaning it's uniform. It goes up, kind of hits the highest point in the center and goes back down. And we will need to know these shapes. The uniform shape is fairly flat all the way across, meaning that every category has about the same number of data points or frequency. A right skewed, it starts out going up and then it comes down and has this little tail on the right hand side. Wherever the tail is, that is which direction it's going to be skewed. So if the tail is on the left hand side, it's what we call left skewed. So if I kind of move that up and look at this picture, notice my tail is on the left hand side here. My hump is on the right hand side. If my tail is on the left hand side, this is left skewed. But if I draw a picture that looks like this, notice my tail is on the right hand side, so this one is going to be right skewed. So it's the direction that your tail is lying on that's going to be the direction of the skewness. Sometimes it may be that it's kind of, okay, this one has a little bit of a tail here, a little bit of a tail here, so we would kind of say that this one is a bell shape, okay? So you can kind of see the differences in some of them, but really kind of look at where is the hump and where is my tail. The side that with your longest tail is going to be the side that it is skewed to. So you definitely need to know your shapes here. Sorry, didn't mean to make us all sick there. But your bell-shaped, your right skewed, and your left skewed are the three biggest shapes that we're going to be looking at this semester. Okay, so if you have any questions, let me know, and then head on to the next video.